Bonjour tout le monde, vous m'entendez?
Oui.
Parfait. Alors, je me présente rapidement. Donc moi, c'est Yann. Je travaille chez HR Team depuis 6 ans maintenant. Et j'ai évolué l'année dernière sur le poste de squad leader. Donc globalement, HR Team essaye de développer du contenu supplémentaire à la fois pour nos consultants, surtout pour nos consultants, et également pour nos clients. Et tout ça divisé en plusieurs squads, squads techniques. Donc là, aujourd'hui, cet événement proposé par Florian et Hassan s'inscrit dans le cadre de notre squad Software Engineering. Je fais rentrer quelqu'un d'autre. 2 petites secondes. Voilà, on est au complet. Donc déjà, merci à tous d'être présents aujourd'hui.
Bonjour.
On a l'occasion, bonjour, je pense l'occasion de se rencontrer sur d'autres événements. Je voulais simplement donc voilà, m'introduire pour ceux qui me connaissent pas, j'en connais quelques-uns. Et je voulais aussi et surtout introduire dans un premier temps Florian qui se trouve à côté de moi, qui va vous introduire aussi le sujet avec Hassan. Ils se sont connus il y a quelques temps. L'objectif, c'est que Florian et Hassan nous parlent, et surtout Hassan nous parle du bouquin qu'il a développé sur le standard. Donc, il reviendra sur l'approche de manière globale et peut-être plus en détail pour ceux qui veulent avoir des détails techniques. Florian rebondira aussi par rapport à son expérience et à la mise en adéquation avec ce standard-là. D'accord ? Ce que je vous propose, il est 18h30. Je vais laisser Florian introduire Hassan prendre le relais. On se laisse une time box, on va dire 1 heure. Je pense que ça peut être.
Ça sera un maximum.
Ça sera un maximum, c'est parfait. Et pour les présents, il y a quelques bières après l'événement. Et pour ceux qui sont en distanciel, la prochaine fois, vous serez ici. Donc, on partagera ce moment-là. Florian, je te laisse la parole. Merci à vous. Je me mets en retrait et je vous laisse échanger ensemble. Merci à vous.
Okay. Bon, bonjour tout le monde, merci Yann. Alors, Florian, je travaille pour HR Team, je suis consultant. Je fais du React et du .NET et j'ai appris à coder tout seul. Et en fait, j'étais pas un programmeur formé en école. Ça, j'ai créé une entreprise, il y avait un besoin, du coup, je me suis mis à programmer parce que mon ingénieur avait besoin d'aide. Et j'ai fermé mon entreprise en 2020. C'était du jouet dédié à apprendre les bases de l'intelligence artificielle aux enfants. Et quand j'ai fermé l'entreprise, je me suis demandé si j'allais faire du développement de produits, faire du project management ou si j'allais continuer la programmation. Et j'ai choisi de continuer à programmer. Et donc, je vais commencer par apprendre à développer en JavaScript et le front-end, c'est un peu le bordel. Et étant donné que j'étais pas diplômé, que je n'avais pas fait de stage, que j'avais développé de mon côté pour faire du MVP, un prototype qui pouvait être testé auprès des clients, une architecture clean, du code propre, il fallait que j'apprenne tout ça. Donc j'ai choisi C# pour avoir des fondations solides et apprendre à coder de manière propre. Et il se trouve qu'au bout d'un moment, quand je me suis senti prêt à intégrer le marché du travail, j'ai eu un besoin qui est arrivé d'un ami qui travaillait avec une association à Lyon pour soutenir des réfugiés qui fuyaient l'Ukraine. Et il se trouve que j'avais une amie qui avait une application qui correspondait à ce besoin-là, parce que pendant la crise syrienne au Canada, il y avait beaucoup de Syriens qui arrivaient au Canada et en fait, ils essayaient de mettre en relation des familles d'accueil et les réfugiés. Et j'ai contacté mon ami pour savoir si on pouvait utiliser leur application pour la crise syrienne, pour cette crise contemporaine, ce qui se passe en Ukraine. Et la réponse qu'elle m'a donnée, c'est notre application, elle n'est pas propre, il n'y a plus personne qui l'utilise, elle n'est plus online. En gros, c'était pas utilisable. Et donc, j'ai compris que le problème, c'était qu'il n'y avait pas de solution tout de suite utilisable, adaptable à n'importe quel association, c'est-à-dire qu'à Lyon ou à Bruxelles, personne peut prendre un stack et faire un site internet pour faire un genre de Airbnb pour les réfugiés. Et ce problème-là, on peut en trouver la solution de manière différente, mais quelque chose qui est important, c'était d'avoir un code open source facilement compréhensible, donc avoir beaucoup de documentation, avoir du code sur lequel on peut passer sans avoir quelqu'un qui nous l'explique. Et c'est là que je suis tombé sur la communauté que Hassan a développée. Donc là, je vais introduire Hassan. I'm gonna introduce you, Hassan, and your work. Alors, Hassan, si vous connaissez les patterns du genre oignon ou les patterns hexagonaux ou le repo pattern, en fait, ce qu'il a fait, c'est une espèce de simplification de toutes ces bonnes choses. Et au lieu d'avoir plein de projets différents, il va vous présenter ça de manière théorique. Après, moi, je peux passer derrière et vous montrer comment ça se passe dans le code. Mais ça m'a permis de me baser sur quelque chose qui était super clean, avec une communauté autour. Et je sais que si je disparais demain, l'application, elle vit sur son GitHub. Son GitHub, il y a beaucoup d'étoiles, il y a beaucoup de gens qui participent à tous ces projets. Donc, je pense que maintenant, je vais laisser la main à Hassan, qui va pouvoir vous montrer directement ce que le standard peut apporter. Donc, OK, Hassan, I'm going to let you introduce yourself and then show what's up with the standard.
Yeah, absolutely. Bonjour, everyone. That's as far as I can do in French. My name is Hassan Habib. I'm a senior engineering lead at Microsoft. I work on mixed reality HoloLens organization, and during my leisure, spare time, I like to, build communities and kind of try to help these communities kind of evolve in terms of knowledge, survival, and also fulfillment. And especially engineering communities. I've been in the tech industry for almost now 22 years, and it's been my pleasure to kind of gather all these thoughts from all these hundreds and hundreds of engineers that I've been working with and just put it in one unique standard that can actually make things easier for everybody everywhere.
Okay, and so do you want to try to draw the architecture to show everything?
Yeah, let me just tell everyone, a little story. There must have been at least one of us in this room that, have been trying to kind of learn something and it's just not coming through. No matter how many times you try to understand this one thing, it's always kind of difficult. And maybe, one of us or some of us at some point in time have been told, hey, maybe this industry is not for you, or maybe computer programming is not for you. It's not easy for you to understand and all that kind of stuff. I was one of these people, and I decided to kind of change the way things are being explained and change the way the world is being explained to me. So I came up with a tiny theory. It's called the tri-nature of everything. And what this theory basically says is that everything in our world today, it doesn't have to be just software. That includes us as well. Any system of any kind, whether it's biological or artificial, these systems, can be comprised of three main components. These components are either dependencies. So this is how we survive. We depend on things. And then we have purposes. And we also have exposures, right? So a simple example for this is the computers that we use every day, right? Your computer requires electricity to run, but the computer itself has its own logical unit within itself to fulfill its purpose. And in order for us to be able to interact with these computers, we need exposure, layer, which is basically the monitors and the, keyboards and the mouse and everything else that you use to interact with a computer. If you look at this theory and apply it to anything you're trying to learn today, you can easily understand any system out there, no matter how complicated the system may be, within these particular, kind of realms and these particular characteristics. Like, for instance, the most complicated, architecture out there, the most complicated systems, enterprise systems out there, they must at some point in time rely on some dependencies, say maybe a database. At some point in time, they have to have their own logical unit that basically processes the data and validates the data and makes the system in and of itself unique in one way or another. And then it must be at some point in time has an exposure layer, which is an API or a UI or a mobile application. No matter what that exposure layer is, even if it's just writing files on a desk, that's still an exposure layer for this particular system. Now, if you look at this, just from a high level perspective, just like this, you might think to yourself, yeah, we've always been seeing this pattern everywhere. What's new about this? What's interesting about this is that if we understand every component in the system and we know how to break it and into certain rules and certain characteristics that makes the system easily maintainable and easily understandable by so many people out there, this way you can build the most complicated systems in the world, and the most junior engineers on your team will be able to understand it and contribute to it from day one. I'm not just saying this just to say that. This is things that I've been seeing, in the last couple of decades, right? So I'll stop here for a second to see if anyone has any questions before I dig a little bit deeper into that. Any questions?
I'm okay. I'm gonna look because Yann is the one looking at the chat. Let's see in the chat if there is sous-titres. And someone wants to know if there is subtitles. So I can maybe go through what Hassan just said. So, alors, je vais faire un tout petit résumé de ce qu'il a dit. Donc, il a parlé d'une théorie qu'il a développée, c'est la nature des choses, et on retrouve ce qu'il a dessiné dans ce qu'on développe aujourd'hui, une séparation de la dépendance. Vous savez, quand on a besoin de parler à des données dont on est dépendant, on essaye de les mettre dans une couche qui nous protège de cette dépendance extérieure. Et donc, il n'y a rien de nouveau quand on voit ce dessin-là, mais justement, il va aller un peu plus loin dans son explication de ce qu'il a essayé de simplifier dans son architecture, tout en approfondissant cette séparation de concern, comment on dit en français? Concern, ouais. Enfin bref. Donc, ok, I think you can continue, Hassan.
Okay, do you want to ask them if anyone has any questions?
Alors malheureusement, ce n'est pas une fonctionnalité posée par Tim. Florian va essayer de réaliser en français. Ok, I'm going to translate sometimes, ok. Je vais traduire de temps en temps. Je vais essayer d'être attentif, ok. I'm going to pay attention à ça. Go ahead.
I'll take little pauses, every now and then, so you can just kind of translate and all that. Okay, so here's the thing. The beautiful thing about this tri-nature pattern is that it's fractal. What that basically means that it repeats itself downwards and upwards, right? So if you look in nature, you can look the structure and the architecture of an atom is almost identical to the structure and architecture of a solar system. So the smallest thing and the biggest thing that we know about, they follow the same fractal pattern that no matter how lower or higher you go, it's just a repetitive pattern that you will see even in some of the, old, codex or architecture writings of, scientists from a long time ago. Now, here's the thing. If you talk to any engineer out there and you tell them there's a UI and an API and a database, they'll be like, I am very familiar with that. But check this out. If I dig deeper into this API, you can break this API itself into three main components, right? The API itself is not just an API. It has a broker unit, and this broker unit knows how to communicate with external resources. It has a service, which is basically just the database. Sorry, it's a C# class or any programming language class that holds a logic in it, validation, processing, and logic. But it also has a controller, which is how you set up your API. So you can see the fractality. The fractal pattern here is repeating itself in a smaller realm. So I'm going to just kind of think about this as a zoom in from a magnifier into this system in here. And this is me zooming in and saying, hey, here's your, even the inside of this particular component itself also has a fractal pattern of a dependency and a purpose and an exposure layer. Let me send that to the back real quick. And I'm gonna intentionally go ahead.
I'm gonna translate. Alors, je fais une petite traduction. Il nous explique que son idée, c'est d'avoir une architecture fractale. Alors, je ne sais pas si vous avez déjà vu des images fractales ou des. Could you show off some images or a GIF of fractal?
Yeah. Yeah, absolutely. Yeah.
Donc, c'est un pattern qui se répète à l'infini. On peut zoomer ou dézoomer et ce sont toujours les mêmes formes qui reviennent. Donc, il me semble que ça vient d'équations mathématiques qui permettent de produire ces images-là. Et donc, le concept de son standard, c'est que c'est toujours les choses viennent par trois. On peut les regarder de loin, c'est-à-dire qu'il y a l'interface utilisateur d'un côté, l'API avec le business qui est au milieu et la base de données. Si on zoome sur l'API, comment elle est construite? Elle est construite de la même manière en trois parties. Une partie qui s'occupe de l'interaction frontale, le service qui va être isolé, et puis après la partie qui va communiquer avec les dépendances extérieures. Les dépendances extérieures, ça peut être la base de données. Voilà. Et donc, encore une fois, il va vouloir rentrer. Si on zoome ou on dézoome, on va essayer de retrouver cette répétition de trois choses. En fait, on pourrait appeler ça un pattern trident, si tu veux. Voilà. Ok, alors, ça c'est une image fractale où on a des images qui se répètent et plus on zoome, plus on va s'apercevoir qu'en fait ce sont toujours les mêmes images qui reviennent. Okay, so I'm done with the explanation of the fractal part and the zooming in, and it's always the same shape.
Okay, all right. So
it's almost harder to me to speak French than English at the moment. I don't know why, but anyway.
It's all right. I'll learn a little bit of French for the next time. How about that? Maybe.
I'm doing my best, guy.
Yeah, I appreciate you, brother. Okay, so there's a fractal pattern. If we can apply this same strategy when we're building software, one of the biggest problems that create chaotic systems today is that these systems, they don't necessarily follow a consistent pattern, which makes it a lot harder to understand. It makes it also a lot harder to maintain, and a long term, it makes it a lot harder to add new features to it. You can see, like, if you look at any graph of any system design, any complicated or enterprise systems, you will notice something very prominent. At the beginning, the system is young and strong, and it gets a lot of features and all that. But as more and more features being added to that system, it becomes harder and harder to maintain that system. This is because these systems don't follow a certain standard, certain pattern, that can be easily understood no matter how large the system is. Go ahead.
Est-ce que quelqu'un a des questions ou a besoin d'explications? Mais je pense que Hassan, the best would be for you to continue.
Okay. Want me to continue? Okay. So,
Pas de question.
Il y a une question ou pas?
No question.
Okay, no question. Okay.
Question. Okay. All right.
And
so
I can add a comment because you just told us that the hard thing in software is to be looking for stuff. Donc, I'm going to share my own experience with it. Donc, une des choses qui vient d'évoquer, c'est que quand on travaille en industrie, quand on arrive sur une nouvelle application, on se demande mais c'est quoi ce bordel, où est-ce que les choses sont, comment on demande d'ajouter cette fonctionnalité, mais je ne sais pas où aller. Et le fait que ce soit standardisé et que ce soit dans une forme qui soit toujours la même, on sait tout de suite où aller chercher le service qu'on doit changer. Et il y a beaucoup de règles qui vont plus loin que dans l'architecture qu'ils proposent. Il y a beaucoup de règles qui vont avec le standard, en fait. C'est pas juste comment on fabrique ces classes ou comment il y a vraiment des priorités comme la duplication du code plutôt que l'utilisation d'un service, un helper ou un manager qui va être introduit sur tous les services parce qu'on va plutôt prioriser le fait que chaque service soit indépendant l'un de l'autre et qu'on puisse par exemple les découper. Donc on sait que s'il y a quelque chose d'écrit qui intervient sur du code, il vit dans cette classe-là, il est là, il n'y a pas un truc magique qui vient de nulle part. Et il priorise ça, en fait, c'est super clean. Et ça aide à ne pas être perdu dans le code, même s'il y a énormément de fichiers. Et comme tous les projets qui sont développés par la communauté du standard respectent exactement cette architecture, ça va jusqu'à l'indentation prête, hein, c'est très strict. On est tous capables de lire n'importe quel projet fabriqué avec ce standard et de participer tout de suite. Okay, so I just said that we were all able to jump into a standard project because they are all respecting the same code practices and the same shape, and we could jump at it really easily.
Absolutely, absolutely. So just to kind of press on, the importance of this, you can see here how I dissected one single API, from the inside. It has a controller and a service and a broker, and no matter how complicated that controller may be, as long as you stick to this terminology and as long as you stick to this categorization of writing your code, things become a lot more clearer, no matter how big the system is. I think one of the last systems that I've written had almost 700,000 lines of code, and yet people will be able to contribute almost within a day or two, depending on how much, they put in to understand the standard, the engineering standard. If you zoom out a little bit, like let's say you're in a microservices architecture, I'm going to take this guy, I'm going to put it in here, right? Microservices architectures or distributed systems as they exist today, they can have many, many smaller services, and these services might have maybe an orchestration, and these orchestrations might have, an exposure layer. So in a big enterprise system, you might see this pattern very, very clearly in certain systems. You'll see many, many services. Maybe there's an orchestration service, maybe a gatekeeper. So I'm going to put in a gatekeeper in here, right? These all are still APIs, but I'm going to call them ambassador API. So ambassador API, like this. So these ambassador APIs are basically services. They don't really hold a lot of the generic high-level business logic of the business, but they know how to maintain a certain, kind of entity or work within a certain domain. So let's say students API, teachers API, or schools API. So it knows how to handle that. But then you have an orchestration API in here, or orchestrator API, and this guy knows how to communicate with everybody and kind of gets the work delegated to it from the gatekeeper pattern all the way down, and basically communicates with these services. If you look at this microservices architecture in this way, you will notice something interesting happen. This fractal pattern is again repeating itself, because now you can see that these guys becomes your broker, your dependencies that feed off the outside world. This guy holds your actual logic, and the gatekeeper becomes the exposure point where your customers are communicating with your microservice architecture through it. So you see, like, this is I'm going a little bit deeper, and even if you zoom out a little bit, you will find that your microservice architecture or distributed system architecture follows the exact same pattern. Now, actually, let me take a second to see, do you want to translate this, or do you want to talk to people about this a little, or should I just continue?
I mean, I guess you should continue because I wouldn't know what to say. I was
Okay.
I was replying to a text and I didn't hear anything really strange. So
Okay, perfect. All right. So let's zoom out even further, right? In big enterprises, right? In big enterprises, you have multiple organizations, right? So every organization has its own kind of team, and these organizations kind of support and serve each other and help each other to kind of complete a larger task. If you look how this pattern repeats itself, you will notice that most of these organizations kind of depend on each other, and they have their own kind of exposure layer, another organization that basically takes care of the exposure, like the UI team that basically sits in something like Microsoft Store or something like that. It doesn't matter what the organization is. You'll find whole teams, whole organizations, hundreds of engineers working across this organization, supporting. They have their own exposure layer. They have their own thing. See, so at the org level, you still have teams that are considered a dependency for other teams that are doing the core business logic, for other teams that are exposing, this to the outside world. So you see how the pattern is repeating itself as you go up, you're zooming out. So no matter how complicated the system may be, if it follows that same pattern, you can, like, an entire company that follows the standard is a company where you can wake up any day and work on any product you like without any downtime, without any learning curve, because it's following that exact same pattern, kind of committedly.
okay, so I can add something. Alors là, il vient de montrer que en zoomant, en dézoomant, on pouvait retrouver la même architecture. En fait, si on fabrique nos applications comme ça nous permet d'avoir une vue claire sur où est-ce qu'on doit intervenir. Parce que si tous les services font leurs choses de chaque côté, ça fait des lignes parallèles, on ne sait pas sur laquelle sauter, alors que si on sait qu'il y a toujours un service qui fédère de la logique, on peut aller sur ce service qui fédère de la logique. Et on retrouve du coup le pattern fractal si on s'organise de cette manière-là. Donc, il y a cette idée d'orchestration de plus petits services ou de dépendance extérieure. Okay, so I just explained that there is an idea of orchestration of other services or dependencies.
Absolutely. So one more thing, if I zoom in, let's zoom in a little bit. Let's take this one service, this one tiny, C# file that holds a little bit of business logic. If you look inside this file, you will see that this file goes through the same pattern. It picks up it does a little bit of validation in here. So here's validation. And then it does a little bit of processing, which is business logic. And then it does a little bit of integration, meaning it calls the broker so it can go do things. So inside that one tiny component, which is a service, it also follows the exact same pattern. It has an exposure layer, it has a processing layer, and it has a dependency layer. Even if you dig even deeper into the validation itself, you will find something very interesting in there. I'll copy this and put it down here. Validations themselves can be logical. Sorry, there is structural, and then logical, and then external, right? So a structural validation is when you go and say, is the string null, empty, or white space? Very basic, top kind of a smoke test to know if the data is in the right format. And then there's logical, where you go and say, okay, students who are enrolled in this school cannot be older than 18 years old or 16 years old or whatever the case may be. That's logical. And then there's external, where you go call an external, dependency, where you go and say, okay, is this student already enrolled in this school? Is this student already, have been before into this, class or something like that? So you see, as you're going up and down, no matter in what direction you're going with your architecture, this pattern continues to repeat itself.
Yeah. So I'm going to translate a bit. So, alors là, et au contraire, au lieu de dézoomer et de montrer qu'on pouvait encore construire de manière fractale, là, il a zoomé sur un service et on peut voir que le service, lui aussi, peut être découpé en 3 parties avec la validation qui représente cette partie d'exposition, le processing, qui est vraiment la logique, le business qu'on est en train de fabriquer, et ensuite la dépendance, l'intégration, c'est-à-dire la communication avec la data layer, par exemple. Et à l'intérieur même de ces 3 parties-là, on peut zoomer et retrouver, par exemple, dans validation, 3 aspects, donc la validation structurelle, la validation logique, et la validation externe, c'est-à-dire que peut-être que nos données, elles doivent être validées par rapport à une donnée qui existe en dehors de notre application. Et encore une fois, tout ça, ça permet de tout de suite savoir où aller chercher sa validation ou alors où l'implémenter. On sait qu'il n'y aura pas de validation dans le contrôleur, on sait qu'il n'y aura pas de validation dans la couche qui parle avec le broker. C'est super propre et ça permet de faire du travail efficace parce qu'on n'est pas perdu même si on change d'application. Okay, so you can continue, I guess.
All right. So if this is a fact that has been established, I thought some certain rules and certain guidelines has to be put in place to make sure that, this continuous investment in the engineering experience. Like when I started writing the standard and collecting these opinions and all that, my ultimate goal was to make sure that I bring what I call fulfillment to engineers. Not just get the job done, not just get the job done right, get the job done right with happiness. Like the engineers are feeling excited about what they're doing. And that's like a secret power that sometimes business doesn't really understand. Like, a lot of people would say, okay, hire 20 engineers, 50 engineers, and let them get the job done. But what if these engineers are not excited about what's being done, right? What if they don't understand what is being done? You'll see a lot of cycles and big organizations around the world that is being wasted on trying to understand chaotic systems and chaotic, architectures, when a simple effort like this, like, very committed effort like this can actually save hundreds, maybe thousands of hours when it comes to, developing and maintaining systems while actually bringing true happiness and enjoyment and fulfillment to the engineers that are building these systems.
Yeah, and I realized I really done a poor job of presenting you and your experience. So, Hassan a beaucoup d'expérience. Il a construit des centaines d'applications. Il travaille chez Microsoft. Et je ne sais pas si vous connaissez l'HoloLens, les senior managers. Là, il est. Where are you living exactly?
HoloLens, mixed reality, Microsoft.
Yeah, so are you using the standards in your department in Microsoft?
Absolutely. It's open source too. Yes.
Ok, so, si vous voulez, vous pouvez trouver des projets open source qui respectent le standard, qui sont développés au sein de Microsoft. Et what kind of application are you developing for the HoloLens?
Experiences, all the experiences internally, end-to-end, integration and building, systems and releasing all these experiences that people use.
Ok, donc des expériences, enfin, c'est des applications qui permettent de vivre des expériences avec l'HoloLens. Et en plus de travailler chez Microsoft, il me semble qu'il y a d'autres entreprises. Et avec toute cette expérience, il s'est mis en tête de créer un standard qui permette de faire en sorte que les développeurs soient heureux. Et il a écrit un bouquin. Et je suis tombé sur lui, voilà, au travers de son bouquin et des vidéos tutoriels qui existent sur YouTube. Et donc, il y a une il y a une bonne communauté qui s'est fédérée de gens qui sont passionnés par la programmation. Et c'est pas seulement du C#. Il y a des gens qui ont qui ont transféré le standard en PHP, en TypeScript. Could you list maybe give us a list of languages that people are trying to port the standard on?
Oh yeah, there's been a lot of people that have been coming to our community. Like you'll see if you go to the standard repository, I gave people some examples in Go, Scala, R, Kotlin, and Java and Python. You can apply it to anything because it's not really specific to .NET or C#. But more importantly, it's also translated into different languages. Like you guys speak French, you'll see the standard available, or at least part of it, translated in the French language. You can go to it today. This is all community-based, crowdsourced, people that actually took in the standard and understood what it's doing, and they went out there, to translate it for people that speak that language locally or natively. So you have both. You have programming language translations, and you also have natural human language translations available, for people for free. You can just go into this repository. It's open source, and you can see what it's doing in there.
Yeah, and it helped me a lot at work. Alors, dans cette communauté, il y a des gens qui sont vraiment super sympas. On peut aller sur Discord. Il y a un Discord qui s'appelle The Stand-Up Community. Il me semble que sur le GitHub, on the GitHub, there is a link to the Discord. No, isn't there?
Yes. If you go, exactly. If you go into the standard, main repository, you will find a link in there to the standard community where people are kind of, the community now is over 500 engineers from all over the world. At this point in time, there is no hour in a day or night, every day that someone is either following the standard or talking about the standard or working towards something that is supposed to upgrade the standard.
Et donc, il y a énormément de programmeurs et j'en ai rencontré qui m'ont conseillé et qui m'ont aidé. Je sais que c'est vrai qu'à n'importe quelle heure de la journée, je peux aller sur le Discord, parler avec ces gars-là. Et en plus, comme on respecte tous le même standard, on essaye du moins, parce qu'on sait que c'est pas quelque chose qui est fixé dans la roche, ça évolue. Donc, on débat pas mal aussi de qu'est-ce qu'on pourrait améliorer dans le standard et qu'est-ce qui est cool, qu'est-ce qui est pas cool. Mais il y a des gens qui sont fantastiques et qui participent au standard en développant des bibliothèques qui vont aider aussi à faire, par exemple, la validation structurelle ou ce genre de choses-là. And I was talking about the standard community and all the guys that are working with us and that are building libraries or Nugget packages to help us do the validation or stuff like that. So I'd like to know if you could show us maybe some code because we are geeks around here and we want some code. We are like Sam. So there is a guy in the community called Sam, and he doesn't like to talk. He just wants code all the time.
Talk cheap. Show me the code, right? That's what Torvald says. Yeah, let's do a quick tour, right? Like we talked about this. This is the theory. All of this is great, but what does this look like in the real world? Like when you look at a simple application or even a complex application, what does this look like, and how does that look like when you're writing code? So let me show you here a quick example of a standard compliant system. Just give me one sec. Let's go here. Let's open up one of the projects that the team is working on these days. It's called OData. You know, some of you might have heard this if you're playing with OData Neo and stuff like that. You'll see that this is a project that we're building in collaboration with the standard community. And if you look at the project itself, let me see here if I can share my screen, and let me know, guys, if you can see it easily. Can everyone see it here? Fine.
I think so.
Okay.
Est-ce que c'est assez gros? Est-ce que c'est assez gros pour tout le monde?
You guys see it okay?
Yeah. I think it's big enough.
I could increase the screen size if you'd like. I'm okay with that too.
I guess it's fine.
Fine? Okay. So
It's big enough.
Okay, so let me just reset some changes here, and let me just show you. You know, we took the standard and we basically said, okay, what can we do, you know, to make things easier for people out there, right? If you look at, you know, the structures of the trees in here, you'll notice that this is a standard compliant system. You'll find services, models, and brokers, right? We don't have exposure layer yet, but I'll show you that in a second. And within your brokers, you'll find that every broker kind of encapsulates some external dependency. So if you're working with, you know, an external dependency like the entity framework, for instance, you know, you'll have a broker in here that takes care of all that external dependency. So it doesn't leak into your core business logic. And you're basically kind of adhering to a certain contract that takes in an expression and returns a raw SQL query. And then upstream to that, you will see that we are at the service layer where we basically can go and say, okay, here's a foundation service. Here's a SQL service that basically relies on this iSQL dependency query. Now watch this part, because this is where it really matters. This is your service. It does the validation work. It does the external dependency work, but also it does, you know, exception handling work. And like I said to you, like when we're building the standard, it's not just about, you know, having a nice sounding theory or just building a system that works. It's also about bringing a good experience to the engineers. Instead of having all the try-catch, the exceptions handling, you know, happen in front of the engineer, we decided to leverage partial classes to kind of imagine, you know, objects in 3D space. We always talk about object-oriented programming. Objects are 3D, they're not 2D, but the way a lot of people program them today is like in a 2D space, like you're seeing everything in one file right in front of you. Instead, we went on to improve, you know, how we write our code. So we basically have this wrapper behind the scene that handles all the exceptions, because exceptions are exceptional. You're not always going to be looking at the exceptions. We also had another one that basically takes care of the validations. And then the main one, the root of this, is basically the one that handles the actual logic. Right. So now when you're looking at this file, you know that exceptions are being handled, you know, validations are being taken care of, and you get to focus on the things that really matters, that makes your system different from another system. All of these practices, it's basically a true materialization of these solid principles. When you go and say, I want test-driven development, I want dependency injection, I want abstraction, I want to be able to, you know, kind of have a separation of concern and have domain-based, you know, concern kind of implementation. This is what that looks like in a simple, easy way that from a junior all the way up to a principal engineer can understand and deal with.
Okay, so I'd like to point out, you know, the partial class, because you know, it's something common for us. Even, so let me explain the trick in French, okay? So, alors, en C#, on peut écrire une classe sur plusieurs fichiers. On a un mot-clé qui s'appelle partial, on le met en face du mot-clé classe, et ensuite, on peut déclarer exactement la même classe dans un autre fichier et mettre de la logique que normalement, on aurait dû mettre dans le même scope, donc dans un seul fichier. Là, grâce à ça, on peut la séparer et le mettre dans plusieurs fichiers. Donc, ça donne l'impression que la validation structurelle, la validation des données vit dans une autre classe, alors que ce n'est pas du tout le cas. Quand il y a une instance de cette classe qui est créée, il n'y a pas une deuxième instance qui est créée pour la validation. Et pour rester concentré sur le business, la validation est dans un autre fichier. Et ensuite, on peut écrire dans le fichier principal les actions qu'on veut faire. Et comme ça nous permet d'être concentré aussi que sur la validation quand on est sur la validation. Au lieu d'avoir des try-catch partout qui polluent un peu la vue, eh ben, on isole tout ça. Et c'est pour ça que c'est très agréable de travailler avec le standard, c'est parce que ça pousse loin la réflexion de l'expérience du développeur et comment on peut réussir à se sentir à l'aise quand on développe. Et il y a plein de petites techniques. So, can you show off the try-catch and how it works? Because
absolutely.
It's a method, and so the method is declared somewhere, okay, and all the try-catches are there.
So this is some sort of what some people call monad, right? Because it's a function that takes another function, right? And this function is basically a delegate. It takes this function in here and passes it and it calls it as is, but then it wraps it up in the try-catch kind of blocks. So this way, this entire block that you see in here is basically an anonymous function that is being passed as a parameter, right? And this parameter is basically what gets executed. So when I call this in the function itself, it goes back and says, okay, call it in here, but wrap it up with try-catch. This way you don't have to worry about, looking at the try-catch exceptions, kind of exception handling, while you're trying to just look at the business logic of the code. It's really important that the presentation of your code is kind of inviting and enticing for people to kind of look at and be able to improve on.
Ok, et alors, donc il vient de dire que la méthode, là, elle prend en paramètre une fonction. Et donc la fonction qu'on passe, c'est une fonction anonyme, et c'est dans cette fonction anonyme qu'on va mettre toute notre business logique. Et donc dans la méthode qui s'appelle try-catch, c'est à cet endroit-là qu'on va décider de comment on va gérer les exceptions qui remontent de cette fonction anonyme qu'on a déclarée pour faire notre business. Des petits tricks comme ça, des petits tips pour avoir, je sais pas, il y en a plein dans le standard, il y a plein de petites choses, plein de petits joyaux qu'on peut trouver pour avoir du code super clean. Okay, so I just translated what you said with the anonymous functions passed in as a parameter.
I think someone left you a question in the chat.
So he said, oh, it's a callback. You mean like the delegate is a callback?
It is like a callback, exactly. You're passing in a function and you're waiting. We're basically executing this function, but within a completely different realm. So this is how we're presenting, kind of separating, having your logic from your exception handling, and still being able to see your logic without having to be kind of have a sight pollution of looking at exception handling. Mm-hmm.
Et donc c'est un callback, là, c'est une histoire de sémantique, c'est en C#, on parle de delegate ou d'action en fonction des paramètres qu'on veut passer au retour, mais oui, c'est une fonction que tu passes à une méthode de notre service. Et donc ça fait... OK, I'm gonna let you continue and we'll see later if...
Yeah, absolutely. If you want to look at, full-blown systems that have been built, kind of, according to the standard, one of the easiest thing that is both beneficial to you and, kind of will give you the inspiration. If you go to nougat.org and you look for anything, I'm going to send you the link here just so people can see, all of these libraries. There's almost a 250,000 downloads to libraries that are developed with and by the standard community. And these libraries support, all across the board. And these libraries, all of them are open source and all of them are standard compliant. For instance, some of the upgrades that we're doing recently is with something called Levent. And Levent is basically a library that allows you to implement a pattern that we call the cul-de-sac that kind of helps us kind of manage events in the system. If you look at the implementation of this library, it's end-to-end built according to the standards. So you have exposure layer, which is clients, you have brokers, and you have services. And inside the services, if you look at the events, for instance, you'll see the event processing service follows the exact same standard. If I pick up Florian or anybody from the standard community who never touched that code ever in their life, they'll be able to make contribution to it today because it follows these exact same patterns and the exact same paradigms.
Donc vous voyez, dans la communauté, il y a pas mal de Nugget packages qui ont été développés, donc ce sont des librairies, et toutes les librairies respectent le standard, et quelqu'un comme moi qui a jamais vu cette librairie-là, je peux arriver directement sur le projet, savoir où est-ce que la logique se trouve, et en plus suivre le code, je sais que la validation est là, et tout ça. Et donc c'est vraiment cool. So there is something I could ask is there is no outside project, another project for the like the data access layer. Like it's not a separate project from the main one. So could you talk about this layer that is responsible for talking to the database?
Yeah, absolutely. I mean, you know, one of the most important things that we want to do today is to basically make sure that you have everything you need in one spot, right? Like sometimes people would like to create smaller projects and then share these projects across other projects. So you see some sort of a pattern of kind of entanglement. That's what we call in the STEM, we call it entanglement, which is basically when you go and say, okay, let me create, especially with microservices architecture, you'll see a lot of people go and create a certain library in here and they call it entities, right? And then they go create maybe a backend project and a UI project, and both of these projects kind of rely on that exact same library like that, right? Or this external project. Let's say this is your API and this is your UI. The problem with that is that this guy here now becomes a point of entanglement, because now two projects are dependent on this library. And while in development time, it seems like it's saving us time, in maintenance and utilization time, it doesn't, right? What we decide to do is that we go and say every project for itself, because there's no guarantee that every project is going to be using the exact same technology. Like, for instance, you could be writing your API in Python, but your UI is written in C# or the other way around. So instead, we said every project should have its own dependencies and should define its own concrete models. Otherwise it would be an anti-pattern where it's kind of breaking the whole idea of being stateless and being independent from one component or another. Most recently, we decided to shift a little bit into something that's even bigger, something that we call standardized provider abstraction libraries. This is the hot topic that's going on right now. And these standardized provider abstraction libraries basically say we need to publish some library out there, and this library, let's call it abstraction X. And this abstraction library is published out there on GitHub. It's published on NuGet packages. And what we want to do, we want any provider out there to publish according to that abstraction. So whether you want to use something like SQL, or you want to use Oracle, or you want to use MySQL or MariaDB, it doesn't matter what library you want to use. These libraries will kind of inherit from that abstraction and basically implement that abstraction, so the consumer that's sitting on the other side that's reading from that abstraction doesn't have to go through the detail of handling specific exceptions per library, and doesn't have to deal with different contracts per library. So today, if you decide in any big enterprise project, if you decide to shift from SQL to Oracle, that's a big problem, because you have to change a lot of things. We don't want you to change these things. We create that provider abstraction library that says, in order for us to do that, we need that abstraction layer that makes sure that whatever new technology you want to use adheres to this middleman that basically is the universal or unified contract between the consumers and the external world. That's a lot of words. Do you think you can translate all of that?
Yeah. So could you show off the storage broker file with the config and everything, and I will explain what you said with the evolution of the approach. But I know where you're coming from with this, but I need to show off the broker.
Yeah, I know.
That you just
Okay, here's an example of a broker. So this is a broker here. So if you go into a
okay, let me introduce the concept of brokers. So some just a translation, because broker, it's not something that we are used to. And so, okay, alors.
Like a liaison. I think liaison is a French word.
Yes, it's good. So, alors, dans le standard, on n'a pas de projet DAL qui est responsable de communiquer avec la base de données. On a une classe qui est énorme, mais qui semble pas énorme parce que justement, on utilise le mot-clé partiel pour découper ça en fichiers. Donc, la couche qui est responsable des entités qui vont communiquer, ça s'appelle le storage broker. Broker, ça veut dire courtier. Et c'est pas simplement un mot qui est utilisé pour parler de communication avec la base de données. Si on a une dépendance extérieure, comme par exemple choper la météo ou le temps ou parler au système, ça va être par exemple dead time broker. Ça va être entity broker. Et là, c'est storage broker. Et donc, on a une classe Could you show up the storage broker class?
Yeah, absolutely. Okay, let's go here. So here's a storage broker. So let's go to storage. If you look at the storage broker, we have an interface like a node, but we also have, so you see we're using partialization, but let's just get into this guy first, right? So you see your storage broker takes a configuration, right? And it configures itself. It owns its own configuration. So whatever that configuration is, it sets itself up. There's nothing external that kind of controls that storage broker other than just passing in the iConfiguration object to it. But more importantly, it defines these generic functions that every other partial class within that particular component will need to use to know how to communicate with it. Like for instance, if I go, for instance, over here to something like efforts broker. So let's go into our trusted sources, right? In trusted sources, you'll see so you have the DB set defined in here, but it's leveraging this generic function that's in that core storage broker to kind of do a retrieval, select all, add, and insert. It depends on the utilization and the usage of this particular entity. Some entities will have implementation that others don't. Like you'll see that efforts, for instance, it has the insert, select all, it has a select by ID and update. Some others don't, right? And this is one thing where we diverge away from this repository pattern, because the repository pattern gives you functionality that may or may not need, right? So it might be a security issue, right? In here, in this pattern, we're basically saying only implement what you need and implement what you need per entity in a partial class. Go ahead.
Yeah, so, donc vous voyez qu'en haut, on voit toujours encore partial class. Donc on est toujours sur la même classe storage broker. Ce qu'il était en train de montrer avant avec abstraction X, c'est qu'on a un problème aujourd'hui que la communauté essaye de régler. Là, on utilise Entity Framework. Donc, s'il y a une exception qui vient de Entity Framework, où est-ce qu'on check si elle arrive? On check ça dans le service, dans les validations. Le problème, c'est qu'on a envie d'isoler le service de l'extérieur. Et là, on permet l'extérieur de dicter le genre d'exception qu'on va avoir à l'intérieur du service. Et donc, une solution qui a été choisie, ça a été de créer une bibliothèque, celle qu'il a appelée abstraction X dans son dessin, pour en fait aller encore plus loin que le broker, pour définir un mécanisme de communication avec une dépendance externe. Comme ça, les exceptions qui arriveront de ce projet sera complètement séparées de notre application, et les exceptions qu'on pourra checker à l'intérieur de notre service seront des exceptions qu'on connaîtra puisqu'elles feront partie du standard. Ensuite, n'importe quel provider d'une dépendance pourra développer une librairie de compatibilité avec ce abstraction X qui est là montré. Donc, qui se retrouve plus loin que la couche de communication avec l'extérieur. So, could you go back on the abstraction X, and when does it position itself to the project broker? You know,
Go back where? Sorry.
So could you go back on Draw.io?
Oh, Draw.io, okay.
Yeah, because I was explaining, I went back to the explanation of abstraction X. And I was saying that we wanted to push the dependence to dependencies away, and abstraction X was the solution.
Yeah, so this project abstraction, or the idea of, standardized provider abstraction libraries, right? We have these brokers kind of still know about entity framework, know about, these technologies and whatnot. Instead, we're going to kind of, take these brokers and put in here a universal abstraction library. And this universal abstraction library, beneath it, has its own brokers and services like subsystems. It's fractal, the way we talked before. And it supports as many technologies as it wants to, as long as these technologies adhere to that contract, while these brokers still continue to communicate with that exposure layer, which is, a unique contract, a universal contract that kind of adheres to whatever. It makes it a lot harder, for the system to change, and it makes it a lot easier for engineers to kind of expect, the right exceptions and standardizations around their dependencies.
Ok. Est-ce que quelqu'un a des questions? Est-ce que vous arrivez à suivre? Ok. Alors, someone, just Florian, there is someone else called Florian, just and said it's really helpful. Et c'est quoi le truc qui est le plus compliqué à suivre?
J'ai du mal à me représenter j'ai du mal à me le représenter en fait.
Ok.
Justement, je voulais rebondir sur ça. Il y a des développeurs de différentes technologies, .NET, PHP ou Node et plein d'autres. Moi, de mon point de vue extérieur, c'est-à-dire pas forcément micro-techno, est-ce qu'il y a des technologies qui sont susceptibles de pas forcément coller avec ce standard, même s'il n'est pas gravé dans la roche? Est-ce qu'il y a des technologies qui sont plus enclins à coller avec ça et d'autres peut-être moins, ou c'est un standard qui peut être adaptable à l'ensemble des technologies? Je pense qu'il y a d'autres développeurs JS aussi parmi les participants. Donc,
je vais lui demander.
Bon, pas de souci. Ouais.
So the question is, how does this apply to other technologies or to other languages? And is it like easy to implement in Java but really hard in Python or something like that? Is there some barrier to entry to other languages to implement the standard?
It depends on the capability of the language, but I, certainly had to go back and say, okay, what can I do? Can I actually apply the standard in different languages, and would these languages actually work, in these particular patterns? So if you scroll down to the standard, I'm going to kind of put the link in there just for people who want to kind of look at the, main repository. You'll find there's standard implementation in R, Kotlin, Python. It's not really specific to a particular language, and it follows pretty much the exact same kind of patterns. Like if you look, for instance, at the services and foundation services, you'll see the exact same pattern. It's just that syntax is a little bit different, but because it's a universal pattern, because it's a universal model, it applies to programming and not even programming. Like if you're writing an article, you need to present your prerequisites, the purpose of your article, and then lastly, the measures of success. You can apply this pattern to anything. It's not even, related to programming necessarily. It can be applied to anything out there. But yeah, for programming languages, it depends. Some programming language has the amount of tooling that you have. Some programming languages don't. Some will take a little bit more effort to standardize. Some won't. But is it possible? Can you actually do it? Yeah, absolutely, 100%. Here's an example in R. Someone took, like, R is not even considered like a general purpose programming language, and someone went out there and actually implemented it in R, which is a very strange syntax to me, but it works. And if I'm looking at it, I know what he's doing in here. He's doing an upsert, he's doing an add, he's doing an update. You know exactly what it's doing, even if you don't understand the language itself. And that's the beauty of standardization, is that you don't have to specifically have experience in Java or JavaScript or anything. If you understand the standard, and if the language or the system that's developed is developed according to standard, programming language is not a problem, because you will find out your way through whatever is being implemented. I don't know if you want to translate that.
Yeah, so, alors moi, j'ai utilisé ça pour fabriquer l'application de réfugié là, dont je parlais. Qui d'ailleurs elle est sur sur son GitHub. Elle n'est pas finie, elle est toujours en développement. Qu'est-ce que ça m'a apporté d'apprendre le standard? Donc ça m'a permis déjà de me forcer à apprendre le standard, un standard qui n'a pas été implémenté par moi. Ça m'a permis d'avoir une référence aussi sur qu'est-ce que c'est que du code bien écrit. Parce que si on n'a aucune référence, c'est difficile de juger. Alors, moi, je suis un débutant. Je veux dire un débutant, en tout cas dans l'industrie, être employé à temps plein en tant que programmeur full-time, c'est nouveau pour moi. Et l'avantage, c'est que ça m'a entraîné à apprendre à travailler sur une grosse base de code. Le désavantage, c'est que tu ne fais pas les choses comme tu as l'habitude de faire. Tu pourrais écrire la même chose dans un contrôleur en 4 lignes et au lieu de faire tout ça. Mais en même temps, le bénéfice, c'est que maintenant, le code vit indépendamment de moi. Même si j'ai écrit 20 lignes au lieu de 2, le code, dans 5 ans, il y a une documentation énorme, d'autres exemples existent dans plein de langages et d'autres personnes peuvent participer sans que ce soit un casse-tête.
Alors, justement, pour rebondir sur Florian, qu'est-ce que tu n'arrivais pas forcément à t'approprier, toi, par rapport à ton expérience à toi
Ouais, enfin, moi, je maîtrise plus l'architecture hexagonale. Voilà, je vois la couche UI, la couche domaine, la couche application, la couche infra, je me le représente. Et là, dans le standard, je n'arrive pas à savoir. Je fais trop une analogie avec de l'architecture hexagonale parce que je ne connais pas le standard du tout. Et du coup, j'arrive pas à voir. J'arrive pas à bien voir le découpage en fait par exemple sur un use case tout simple, un formulaire où j'édite les informations d'un utilisateur. Quelle action va où, enfin quelle responsabilité va où? La couche design, on va dire, la couche métier, où est-ce que je le mets dans le standard? La couche stockage, comment elle est décorrélée si un jour je change le MySQL à une API, comment je respecte l'interface qui permettra de changer
l'architecture hexagonale vers le standard.
Non, pas forcément, mais
savoir comment c'est séparé, comment on s'organise.
J'imagine que le jour où je veux plus faire du MySQL, mais faire du Oracle, j'ai juste à réimplémenter les interfaces, j'imagine.
Alors, en fait, là, pour l'instant, il faudrait retravailler sur un seul fichier. C'est là où il y a toutes les configurations. Enfin, non, c'est pas vrai, mais... en fait, les configurations de la communication avec la base de données sont dans le storage broker.
Ouais.
Le storage broker, il faut que tu imagines, en fait, c'est un seul fichier. On a l'impression que c'est plein de fichiers parce qu'on les a séparés en partiels, mais en fait, il n'y en a qu'un. Et la configuration de ta communication avec la base de données se trouve à cet endroit-là, à aucun autre endroit dans l'application. Il va falloir que tu changes d'autres trucs, par exemple par rapport au service, dans les validations, parce que du coup, là, les exceptions que tu vas recevoir de ta base de données ou de ton ORM sont typées et elles sont spécifiques à ce que tu utilises, et donc tu vas devoir aussi changer là. Mais vraiment, c'est OK. I'm just finishing with an explanation. Il faut juste se dire, c'est toujours simple. Il y a trois choses. C'est couche d'exposition, couche qui s'occupe de la logique et une couche qui s'occupe avec la communication, la dépendance extérieure. Et extérieur, ça veut dire si tu dépends d'une donnée qui est pas gérée par toi. C'est-à-dire que si, par exemple, tu dois aller faire une requête à Météo France, tu vas faire un broker qui va s'appeler Weather Broker. Et là, tu vas attendre qu'on te réponde, mais tu vas créer, du coup, tu vas le définir comme ça, en disant que voilà, c'est un broker parce que je communique avec des données extérieures. Après, tu as ta couche qui s'occupe de la logique, c'est-à-dire qui va récupérer ces données-là et en faire quelque chose. Ça va être dans ton service. Là, tu vas avoir, par exemple, un weather service. Et là, dans ce weather service, il est au maximum complètement isolé du monde. Il y a toute ta logique, ta validation structurelle, tout ça qui se passe à cet endroit-là.
Ouais.
Et ensuite, tu renvoies cette réponse à ta couche d'exposition. Le truc, c'est que si tu as besoin de faire quelque chose de plus en plus complexe, c'est là que le concept d'orchestration arrive. Et du coup, les services, on se limite à 3 services qu'on va faire interagir entre eux sur une couche d'exposition. S'il y a plus que 3 services qui interagissent entre eux dans une couche d'exposition, on va créer un nouveau service qui va s'appeler orchestration et qui, lui, va s'occuper de gérer 3 services qui font de la logique, qui répondent. Dans ce service d'orchestration, on va faire quelque chose et lui, il va aller vers un contrôleur, une couche d'exposition. Donc, un contrôleur, c'est ce qui va permettre à un UI de parler et d'avoir des réponses. So, could you show us how it's scalable, like the complexity of an application is related to the different services you have? So, if you have a lot of services that have to, talk to themselves to do some stuff, how do you do this?
Okay, yeah, absolutely. So let's take an example here. Let's say, for instance, that you have, I'll show you here a real life example of complexity that is growing based on the requirements that are coming in. So let's say we're building a schooling system, just a normal schooling system. So you basically built, you know, all we want to do is just add students and add teachers, right? So I'm going in here and saying, here is my students storage broker in here, and then I also have my teachers storage broker, right? So just two brokers, they talk to the database, no problem there. And then I'm going to add this here, and then I'm going to add this here, and this is done. This is your student's controller, like this. That's an API controller, and this is your teacher's API controller. This is the first requirement, people coming in and saying, hey, we need to add students and we need to add teachers in the system, and thank you, we don't want anything else. So far, so good. This is stage one, right? But let's just say the customer came in the next day and they said, okay, I want these, you know, students, I want to map students to teachers, right? So I want to know, you know, for every student, you know, who are the teachers that are responsible for teaching these students, right? Look how this is going to scale. A lot of people today will just go and say, add logic here or here. Right? They say, hey, let's just have the student service talk to this, and let's have this guy talk to this, and let's just complicate things, right? Instead of doing that, what the standard says, no, we can do this better. We can go down here, and we can go and say, okay, keep these existing controllers as is, but since you are now mixing two entities, then you need a new concern, a new service, that is called the student teacher entity. What this guy does is that it goes and says, this is student teacher orchestration service. And what this service does, it just that delegates the work. So when you're getting a student teacher request, you can now have a specific model and a specific pattern. So this is student teacher, right? Controllers. And this student teacher controller is just responsible for communicating with that orchestration service, which delegates the work to these two entities. So this way you haven't touched your existing logic in any way. You're just building on top of it, right? The same thing applies when the system gets more and more complex. Like for instance, let's say for instance, you have other entities sitting in here and you want to orchestrate. You can have orchestration of orchestrations, which is basically a coordination service that's sitting on top of here, that basically says, I want to mold together multiple entities. You can see in every single state, you're basically doing some sort of normalization, but in terms of architecture and programming language, you're basically going and saying, okay, every one of these should either do the work or delegate the work, but not both. So these guys here are delegating work to foundation services, but these orchestration services are basically handling, you know, combining these entities together and producing a new capability that combines 2 or 3 entities together. At the top of this, you could have something like a coordination service like this, right? Now, for a lot of people, they might say, okay, Hassan, you know, how far can you go, right? We can go all the way up to management services, but you can also scale. This is a scale, horizontal scale. We can also scale vertically. What that basically means is that you can go and say, I want to send an event and all the listeners to that event, something that we call the cul-de-sac. What that basically means is that you have this orchestration service, but instead of having this coordination service working with everybody, you have an event sitting in here, and whoever is listening in on that event will be able to handle that. So you're sending an event downstream like this, and the event comes back to the next service, and the next service, and the next service. Questions?
Donc, I'm going to translate quickly. So, alors, par exemple, on a des élèves et des profs, et on a envie de mettre un lien entre les élèves et les profs. On a envie de dire, voilà, les élèves de 5e 1, ils ont tel prof principal. Au lieu de faire en sorte que le service qui s'occupe des élèves parle avec le service qui s'occupe des profs, on va avoir un service qui va orchestrer la communication entre ces deux services-là. Et encore une fois, ce n'est pas nécessairement la méthode qui est la plus simple, la plus jolie. C'est surtout quelque chose qui permet de prédire où est-ce que le code va être et d'avoir quelque chose de clean au travers de toutes ces applications. Donc, au travail, la première source de problème, c'est où est-ce que je dois changer ça, où est-ce que je dois implémenter, comment je dois nommer. Et à chaque fois qu'on a quelque chose qui est dépendant d'une classe généraliste, ah, mais là, si j'essaye de faire un truc, ça va pas marcher, il va y avoir, si je la change, ça va tout casser. Quand c'est séparé comme ça, si on change un service, on sait qu'on n'est pas en train de se détruire. Et la complexité, elle évolue aussi de la même manière parfois.
Je voulais simplement rebondir. Elias était un développeur .NET, si je ne me trompe pas, assez expérimenté. Je voulais déjà savoir si ça te faisait écho ou pas. Qu'est-ce qui te parle moins de manière globale pour qu'on ait aussi un retour d'expérience de quelqu'un qui utilise la même techno que Hassan et que Florian, en l'occurrence?
Oui, je vois un peu bien l'idée de séparation. Après, moi, ce que j'ai comme commentaire, c'est que, on va dire, là, c'est un pattern d'organisation. Moi, quand je rentre, je sais que c'est ça utilise ce pattern, je peux comprendre le code, comment ça marche. Mais j'ai la même chose parce que moi, par exemple, j'ai l'architecture hexagonale et j'ai le même refus. Par exemple, moi, si un nouveau développeur arrive, je lui dis, est-ce que tu as fait l'architecture hexagonale? Il va me dire oui. Donc après, il va regarder l'application, il va tout comprendre. Donc, qu'est-ce que ça va rajouter par rapport à ce qu'on a à l'existant?
Okay. So Hassan, I don't know if you heard, but we'd like to know the main difference or advantages that the standard is giving. Like, I mean, could you compare the standard to the hexagonal pattern or the onion pattern, and what are the advantages that the standard is giving us?
Yeah, absolutely. So first of all, the standard has a principle called level 0. What that level 0 means is that it's easy to digest and understand. Like, it's already playing with concepts you already know: CRUD operations, add data, remove data. It's just basically trying to kind of help you, just so people understand. The standard is not a pattern. It's an entire ecosystem of development that has many patterns and principles within it. Like, you will see it implementing things like, dependency injection, doing things like separation of concern, doing all these kind of things. So I see sometimes people say, okay, what's the difference between the standard and CQRS, or the standard and this other pattern? It's not like that. It's more like a full end-to-end framework that basically even governs how code is being committed and how code is being retrieved and all that. So it has like this full depth. But one of the biggest advantage of it, or at least what I heard from people, some of the junior engineers that started learning the standard, they said something very interesting. They said the standard have turned me from someone who is feeling kind of anxiety and not feeling comfortable being in the tech industry into being empowered. Why is that? Because it stays at this level zero, and it makes sure that it stays on that level 0. A lot of the patterns that are out there require certain prerequisites. Like, it requires you to know a lot of things in order for you to get to that point, right? What the standard does is that it goes and says, no, this is already what you have today, and I'm just going to add very small touches on top of it to make sure that you are able to leverage what you already know to get it in there. That's, of course, in addition to test-driven development, pair programming, all of these nice practices that actually makes the engineering process enjoyable. The biggest value of the standard, though, and this is the thing that I want everyone here to understand, is that the biggest value of the standard is that it's the accumulation of experiences from hundreds of engineers in over 20 years time frame. So we are basically building on top of what the best engineers out there could offer to help you write the most simple and easy to understand line of code ever. It's not there to help you get the job done. There's 50,000 other patterns out there that will help you get the job done. It's there to help you get the job done right with joy. And that's the most important part about it.
Okay. Ok, est-ce que je dois traduire?
Je viens.
Ok, alors là il a dit que c'était pas seulement fait pour, enfin c'est pas seulement un pattern qui concurrence l'hexagonal, l'oignon ou quoi, c'est tout un écosystème pour faire en sorte que les développeurs soient heureux au quotidien. Et c'est vrai que tout est standardisé, même la manière dont tu vas commit, il y a des règles par rapport à ça. Et il faut que je branche mon PC, je manque de batterie. Qu'est-ce qu'il a dit d'autre?
Globalement, on est sur une approche un petit peu plus globale.
Oui, c'est ça. Et le truc, c'est que ça s'inspire de beaucoup d'autres patterns comme l'oignon, mais sans la couche de repository. Et en fait, ça rend les choses super simples. Et le premier truc qu'il a dit, c'est le level 0. C'est-à-dire que tu peux être vraiment un débutant, tu connais les bases de C# et de .NET, et tout de suite, tu n'as pas vraiment de concept compliqué à apprendre pour développer une application complexe. Et c'est vrai que prioriser la simplification, c'est quelque chose qui m'a beaucoup aidé. Quand je suis arrivé dans ma boîte et que j'ai vu un DAL, j'ai mis un peu de temps. Quand j'ai vu le repository, j'ai mis un peu de temps. Et puis tout de suite, ça a cliqué. En fait, c'est juste un storage broker. OK, je vois comment c'est fabriqué. Et tout de suite, après, il y a ces trucs que tu connais, dépendance d'injection, tout ça. Et tu touches à des concepts qui sont compliqués, mais comme je t'ai dit, il y a vraiment une emphase sur du code simple. So, you're prioritizing simple code over smart code, aren't you?
Yes, always simple code. If you keep it simple, you'll be able to withstand any complexity, no matter how it is.
Oh, sorry, I had to plug my laptop.
The one thing I want to press on, Florian, just for everybody here to understand, not every code that is easy to write is simply easier to read. Usually it's the opposite. When you put enough effort in your code to make sure that it is readable, it becomes readable. When you cut corners and you say, oh, let me get this magical thing, this one helper or common library or this one thing fit all kind of library that will do all the work for me, later on the maintenance of that code becomes harder and harder. So you can spend a little bit more time into the writing so the reading is easy, or you can spend less time in writing and more time in maintenance and reading. It's always going in these opposite direction.
Et donc le code, il peut être facile à écrire, mais il peut être difficile à lire. Et c'est vraiment ça le truc le plus important, c'est essayer de rendre la vie du développeur vraiment plus facile. Et il y a des règles comme le pair programming qui font partie du standard, où on essaye de prioriser le pair programming en TDD pour par exemple, pourquoi? Pour rendre le quotidien plus agréable, faire en sorte que les connaissances d'une application ou les tricks comme ça peuvent passer dans une équipe. Et le TDD aussi, ça permet d'avoir un historique de comment l'application a été développée et tu peux aussi apprendre des autres. So I used the GitHub history. I used the GitHub history to learn the standard because of the TDD in it. Again, all the applications are developed in TDD. Donc le TDD, c'est quoi? C'est Test Driven Development. Ça veut dire qu'on va commencer à écrire un test unitaire et on va décrire ce qu'on veut implémenter comme logique. Ensuite, on exécute le test fail. Là, on va faire un commit. Pourquoi on fait un commit? Pour garder une trace du fait qu'on veut cette implémentation, cette feature, mais qu'elle n'existe pas encore. Ensuite, on la fabrique, on recommit avec un test qui passe cette fois-ci parce que justement, ça a été implémenté. Et ça fait vraiment partie du standard. Donc, c'est vraiment pas juste une architecture, c'est tout un état d'esprit, toute une communauté qui permet de laisser des repos de code faciles à reprendre. Vraiment, moi, ça m'a vachement aidé de pouvoir regarder l'historique et dire, OK, comment j'ajoute de la logique qui permet de faire ce qu'il a démontré avec Student Teacher. Et j'ai juste cherché dans les autres projets ce qui existait et j'ai regardé l'historique des commits et c'était super clair, super clean.
Mais messieurs, juste, je me permets, Elias, après, il y avait Dan qui avait une question sur le chat avant que les participants éventuellement posent leurs questions. Florian, est-ce que éventuellement tu peux nous en dire plus sur sa question et notamment sur une approche PHP. In PHP, we don't have a partial classes, maybe using threads. Okay. Est-ce que vous pouvez rebondir sur ça? Et à la suite de ça, je pense qu'Iliès aura une question. Et les participants en ligne, n'hésitez pas aussi à rebondir. On se laisse, Hassan a fait un gros boulot aussi avec Florian. On se laisse une dizaine de minutes pour terminer tout ça. Donc, n'hésitez pas à poser vos questions.
Ok, so we are going to handle some, ask the people some questions. So the first question is, how do you do without partial classes? In PHP, PHP.
Oh, without partial classes, there's a lot of different languages that kind of solve that problem in different ways. Like for instance, in Rust, for instance, they have these idea of modules and crates, right? So in Java, you can do the same thing with packages, right? So there gotta be a way in every other language to kind of represent, you know, the same capability, just different files. And I don't mind, like for some languages who don't support partial classes, to have one folder that has student service and student service exceptions and student service validations without partialization, like just an independent project or an independent class that you're leveraging to kind of do that support. That would be one way to solve that problem.
D'accord. Et tu aurais une question?
Yeah. My question is it sometime that trying to standardize everything could be make things harder? If I give you an example, I work in, let's say, in microservices architecture. I have my backend that is on hexagonal architecture, and my frontend that uses Angular is in flat architecture with component. And if I try to make everything standardized, maybe I oblige myself to do things and makes it harder for me to.
Yeah, that's a great question. So it depends on how much. So let me tell you this today. Let's say you have this system and you're developing different components in that system in different architectures, right? Do you want people to be able to add features quickly and rapidly and be able to maintain your system, or do you want them to spend more time trying to understand each and every single different architecture? It's really all about that, right? Like if you unify and standardize the architecture across your entire distributed system, it'll become much easier for people to help you build that system and kind of contribute to that system and be able to push more features into that system rather than just kind of building every piece in a different way or a different architecture in general. That would be, now you have to know there's a risk that comes with this. You know, it takes a lot of work and a lot of dedication to standardize systems. Like you're not just going to do this and everything's just going to be standardized. It's going to take a lot of time and a lot of effort, but it's totally a worthy endeavor because it's going to make it easier for people to come join you in your project and be able to build that system with you. Like Florian just did with his refugee project. A lot of people from the standard community were able to join in and help him from everywhere around the world, even though they never met the guy ever in their life, because he's following the exact same pattern, the exact same standard. It's like speaking the same language, basically. Go ahead.
Oui, le fait que ce soit standardisé, c'est vrai que ça peut rendre les choses plus compliquées et ça peut rendre les choses plus compliquées parce que tu te retrouves paralysé. Tu as envie il faut que ce soit bien fait et puis c'est très demandant. C'est comme, tu as envie de faire du beau code. C'est du code beau et du code simple et parfois tu vas avoir peur de travailler parce que tu vas te dire, oh non, mais est-ce qu'il faut que je fasse ça comme ça, comme ça? Mais un autre truc, c'est que tu sais que de toute manière, tu peux aller voir plein d'exemples d'implémentation. Et en plus, tu sais que tu peux te reposer sur la communauté. Et comme c'est standardisé, il y a des gens qui développent des outils pour t'aider. Par exemple, quand je me suis lancé, ça n'existait pas encore, mais il y a un gars qui s'appelle Christo Dutoy qui a inventé un plugin pour Visual Studio où maybe in 10 minutes, en 10 minutes, tu cliques sur un bouton et ça te crée tous le broker, le service, le contrôleur, et après ça te fait tous les commits, le TDD, et ça te génère le code que tu taperais ça en une demi-journée et ça te le fait en 5 minutes. Et ça, tu bénéficies de ça parce que justement, comme le standard est vachement pensé pour le travail en groupe, et ben c'est vrai que ça peut te bloquer, mais il y a aussi ça qui peut vachement t'aider.
Oui, je vois.
On vient de recevoir deux questions intéressantes. Je pense que Florian va les relayer. La première de Marc, je développe en PLSQL, Oracle. Je ne sais pas si ces différents langages sont adaptables au standard. Alors, sans forcément revenir sur la compatibilité du standard avec l'ensemble des technos, est-ce que tu peux relayer ça, Florian, et avoir l'avis d'Hassan sur ce sujet-là?
So, someone asked So he's saying, I'm developing in PL, SQL, Oracle, KSH, Bash, and VBA Excel. I don't know if the standards apply. So what
Yeah,
do you...
it doesn't dictate a certain technology. It's a pattern that applies to any technology you're working with, whether you're working with C# or Java, SQL, or Oracle. What I recommend, though, is that you read the part in the standard about SPAL, standardized provider abstraction libraries, you know, and make sure you can build a component that can support all of these different technologies, so you don't have to change your code often every time you switch from one technology to the other.
So you mean you want them to read which chapter in the book?
The standard provider abstraction library. So let me kind of share this with you here.
Chapter?
Yeah, it's a chapter in the standard that it's in the brokers chapter, because it's you know, it's relevant there because of the integration and stuff. You know, I just sent it in the chat. It talks about specifically, you know, the ability to kind of build separated components that can, you know, kind of help people when they're using their brokers. They're working with one abstraction library that has many implementations for different technologies. That's the one recommendation I have. By using the technology itself is not a problem. And I'm sorry to do this, but I have to run because they're a little bit over time. But hey, if you guys have any questions, either join our Discord channel, the standard community, or feel free to just communicate with Florian, and I'll be more than happy to, you know, kind of answer your questions and follow up with you. I'm sorry I have to step out.
Thanks a lot, Hassan. You gave a lot already. So
I appreciate you.
Thank you.
Thanks a lot.
Thank you so much.
Thank you so much.
Thank you so much.
Have a
Take care.
good day.
Take care.
Bye-bye.
Ah.